Okay, I'd like to recap something that hopefully will be trivial to you, but it's something that you're going to need to use to do something slightly more complicated. So what I'm going to look at is just rounding. I'm going to look at rounding to decimal places and significant figures, and I am assuming that you can already round to the nearest 10, 100,000, powers of 10. So this is my number that I'm going to work with, 39.3794. It's just a random number. I'm going to round it to a few different decimal places and significant figures. I'm going to have a little play with it, and then you can have a play with yours. Okay, let's start by rounding it to one decimal place. If I was to round that to one decimal place, it would mean that after the decimal point, we're only allowing one number. So 39.3794 to one decimal place. Here's the decimal point. I come to the first number after it, and I imagine there's a wall there, a line, whatever you want to call it. This number here, just to the right of the line I've drawn. If that is 5 or above, then this number goes up. If that is below 5, then this number stays the same. 7 is clearly 5 or above, and so the 3 becomes a 4. And so that equals 39.4, and I would always write 1 dp in brackets to show that I've rounded it to one decimal place. Now I can do the same to two decimal places or three decimal places if I want to. 39.3794. If I'm rounding to two decimal places, here's my decimal point. I come two places after the decimal, and that's where my imaginary wall line. I guess it isn't imaginary because I've drawn it. The number to the right of the line, is it 5 or above? Yes, it is. And so that 7 will become an 8. The 3 is unaffected. And so to two decimal places, I get 39.38. And I would write in brackets 2 dp for decimal places. If I want to go to three decimal places, 0.3794 to three decimal places, that means we're going to have three numbers after the decimal point. So 1, 2, 3, that's my barrier. This 4 is not 5 or above, so that 9 stays as it is. And so I get 39.379, and that is to three decimal places. Decimal places then straightforward. If you'd like to pause the video then and have a go at rounding 48.5621 to one decimal place, two decimal place, and three decimal places. And if you then press play again, I'll be here waiting to give you the answers. Don't take too long though, because I can't wait all day. Okay, here I am. 48.5621 to one decimal place. 48.5621. One decimal place means one number after the decimal point. Here's our barrier. The number to the right, is it 5 or above? Yes, it is. So that 5 becomes a 6, and I get 48.6 to one decimal place. 48.5621 to two decimal places. So two numbers after the decimal point. Here's our barrier. The number to the right, is it 5 or above? No, it isn't. It's 2. So that 6 stays the same. And I get 48.56. There are now two numbers after the decimal point, as you would have if you were working with money, for example. And then finally, for this little bit, I've got 48.5621, and I've decided to go to three decimal places. So here's my three numbers, 1, 2, 3. There's my wall. This time to the right of the wall is a 1. 1 is not 5 or above, and so the 2 stays as it is, and I get 48.562. And that was to three decimal places. You can round to as many decimal places as you're asked to. The technique is the same. coming back then to my number, which was 39.3794, what about if I wanted to go significant figures? Now, significant figures are slightly different from decimal places. Significant figures means you have 1 or 2 or 3 or whatever the number of significant figures, put my teeth in, is, and everything else goes to 0. So if I wanted to round 39.3794, 39.3794 to one significant figure. The first significant figure here is this 3, which is representing 3 tens. To one significant figure, I draw my barrier there. Because this is a 9 to the right of the barrier, it means that I take the 3 up. Everything else goes to 0. So the 9, the 3, the 7, the 9 and the 4 go to 0. Now what you've really got is 40 point and a few zeros, but I won't write all of them because the number 40 we would just write as 40, and that's still one significant figure. SF for significant figure. To two significant figures, I'm allowed to have two things that aren't naught. So 39.3794, two significant figures this time, 1, 2, and there's the barrier. The decimal point doesn't really matter. The number after the barrier is the 3. Is 3 5 or above? No, it's not. And so the 9 stays as it is, and so that becomes 39 to two significant figures. Now you'll notice here there's only one thing that isn't 0. Here there are two things that aren't 0. If I move on to three significant figures, there will be 3 things that are not 0. So 39.3794 to 3 significant figures. I go 1, 2, 3, and then I put a barrier. The number to the right of the 3 here is a 7. Is 7 5 or above? Yes, it is. So that 3 becomes a 4, and I get 39.4. Everything else goes to 0. The 7, the 9, and the 4 go to 0. But as you know, you would usually just write that as 39.4, and you'll notice this time that there are 3 numbers that are not 0, and that's because I've gone to 3 significant figures. Okay. If you could try 48.5621 to 1, then 2, then 3 significant figures, and then unpause the video and you'll see the answers. Great stuff. So 48.5621, 48.5621. First of all, to one significant figure. I'm only allowed one thing that isn't naught. It's going to be this digit. What is it, a 4 or a 5? Well, this is an 8. Is 8 5 or above? Yes, it is. So the 4 becomes a 5. Everything else becomes a 0, and I get 50 to one significant figure. To two significant figures, 48.5621. This time I'm going to have 2 digits, 1, 2, that are allowed. Number to the right is a 5. Is 5 5 or above? Yes, it is. And so the 8 becomes a 9. And so I get 49. These all go to 0, so it's 49 to two significant figures. And to 3 significant figures then, I've got 48.5621 to 3 significant figures. 1, 2, 3, and here's my barrier. Is the number 6 5 or above? Yes, it is. And so the 5 becomes a 6, and I get 48.6. Everything else goes to naught to 3 significant figures. Okay. Now then, significant figures will also work with integers. They don't have to be decimals. So like here, for example, 2,345. I can round this to one significant figure. So I'm just going to write this down, one significant figure. Technique is the same. One thing is allowed to not be 0. And it's going to be this 2. If I draw a line, the number to the right of it is a 3. 3 is not 5 or above, and so the 2 stays as it is. These other 3 things become 0. You must write them, because if you don't, you will drastically alter the magnitude of the number. 2,345 by no measure should round to 2. It rounds to 2,000. To two significant figures. 2,345. 1, 2 things that are allowed to not be naught. The number to the right of my 3 is a 4. Is 4 5 or above? Nope. And so the 3 stays as it is. 2, 3, the 4 and the 5 are zeros. I mean, we can keep going, but let's do 3 significant figures because I've got space. 1, 2, 3 this time. Is the number to the right of the 4 5 or above? Yes, it is. It's 5, actually. And so that 4 will become a 5. 2, 3, 5. This 5 becomes a 0. Beautiful. Pause the video. Have a go at rounding 6,789 to one significant figure, 2 significant figures, and 3 significant figures. And when you're done, press play and you'll get the answers. Welcome back. 6,789 to one significant figure. I think if I put my barrier here, that this 7 makes the 6 become a 7, and these other 3 will become zeros. To 2 significant figures, we've got 2 things in there. The 8 to the right of the 7 is 5 or above, and so the 7 becomes an 8. So I get 6, 8, 0, 0. 6,800 to 2 significant figures. And to 3 significant figures, I'll count 1, 2, 3 places from my barrier. This 9 is 5 or above, and so this 8 becomes a 9, and I get 6, 7, 9, 0 to 3 significant figures, 6,790. The more significant figures you round to, the more accurate your answer, but it will very much depend on what the purpose of your rounding is. A little quirk of significant figures that I want to share with you is this. The number 0.00234. If I round that to 1 decimal place, it rounds to 0. If I round it to 2 decimal places, it rounds to 0, which is entirely unuseful because this is a number that does exist. I can round it to significant figures. If I just used the technique I've been using so far, then to 1 significant figure, you might think 0. You might think that, but you'd be wrong. And that is because we don't class these first 3 zeros as being significant. The first significant figure in this particular sum is the 2. Then the 3 is the second significant figure, the 4 is the third significant figure. So to 1 significant figure, this becomes no. That's my first significant figure, so that's where my barrier goes. Is the 3 5 or above? No, it isn't, and so the 2 stays as it is, and so to 1 significant figure, I get 0.002. These things have become 0. Similarly, to 2 significant figures, they're not significant. That's the first, that's the second, That's where the barrier would go. Is this 4, 5 or above? No, yes, no it isn't. And so the 3 will stay as a 3. 0.0023. And look, there are two things that are non-zero. Here there is one thing that is non-zero. Pause the video, have a go around in this, just to 1 and 2 significant figures, and then come back and I will go through the answer. Okay, so 1 significant figure. Not significant, not significant, not significant. So the first significant figure is 4. That's where my barrier would be. This 5 tells me to round the 4 to a 5, and I get 0.005. And to 2 significant figures, remember those zeros are not significant. 1, 2 significant figures. This 6 tells me to round that 5 to a 6, and I get 0.0046. Whoops-a-daisy. I'll have to sack the cameraman. Yeah, so 0.0046. One thing to note, if I had a number like 0.002034, these zeros are not significant, but that one is. So to 2 significant figures, this would be 0.0020. To 3 significant figures, it would be 0.00203. So if the 0 is in between some non-zero digits, then it is significant. These ones at the start, though, aren't. They're holding a place. They're making sure we know that there are no tenths and no hundredths, but there are 2 thousandths. Okay. Bit of a long video, that one, but I hope you've enjoyed it. It's something that I think you will have seen before, but it's worth making sure that you can do it, because when we move on to the next topic, which will be bounds, it's incredibly important. So go to Hegarty Maths and try these exercises that I've set for you there. Thank you so much.